There is a very particular moment in science when a discovery quietly stops being just data and begins to accumulate meaning. At first, everything looks routine. Numbers appear on a screen, coordinates are logged, calculations are checked and rechecked. Nothing dramatic, nothing cinematic. Just another entry in a database that grows larger every night. But then something subtle changes. The measurements remain precise, the physics remains intact, yet the narrative around the discovery begins to expand. Questions multiply faster than answers. Hypotheses start to branch in every direction. And slowly, almost imperceptibly, what began as a simple observation starts to feel like the opening chapter of a much bigger story. This is the moment when science and curiosity begin to move at slightly different speeds. The equations walk calmly. The imagination starts to run. Researchers stay grounded in evidence, but the broader conversation begins to explore possibilities that stretch far beyond the initial detection. It is not sensationalism. It is the natural human reaction to encountering something rare, unfamiliar, and profoundly distant. That delicate transition, when a faint signal turns into a global scientific conversation, is exactly how the story of 3I Atlas began. It did not arrive with headlines or dramatic announcements. There was no sudden press conference or urgent alert. At the beginning, it was nothing more than a small, moving point of light, quietly crossing the background of countless stars. A discreet traveler drifting through the vastness of space, indistinguishable from thousands of other faint objects, recorded every night by automated sky surveys. For a brief moment, it was simply another catalog number waiting to be processed, verified, and archived. But space has a way of turning the ordinary into the extraordinary when given enough time and enough attention. Within days, that modest point of light stopped being just another entry in a database. It began to attract scrutiny, then curiosity, then debate. The object slowly moved into a fascinating gray zone, a place where rigorous astronomy meets speculation, where hard science coexists with one of humanity's oldest and most persistent questions. Are we truly alone in the universe? What initially looked like a routine detection rapidly evolved into one of the most discussed topics in modern astronomy. The reason for this sudden shift is deceptively simple. This is not merely another comet wandering through the solar system. This is only the third interstellar object ever confirmed to pass through our cosmic neighborhood. Only the third visitor from another star system detected since humanity developed instruments sensitive enough to notice such fleeting travelers. In purely scientific terms, that fact alone would already make the discovery historic. But 3I Atlas quickly proved that its story would not end there. From the very beginning, the object displayed characteristics that pulled it into a much brighter spotlight. Early measurements suggested a nucleus between 6 and 9 kilometers in diameter, roughly 3.7 to 5.6 miles across, a size comparable to Manhattan Island. For an object that has spent millions, perhaps billions of years wandering the interstellar void, this is enormous. Interstellar space is not kind to fragile bodies. Over vast stretches of time, radiation, collisions, and gravitational encounters tend to erode, fragment, and disperse smaller objects. The mere survival of something this large immediately raised eyebrows. Its speed added another layer of intrigue. Traveling at more than 80,000 miles per hour, 3I Atlas is moving fast enough to cross the distance between New York and Los Angeles in just over a minute. That velocity is not unusual for interstellar objects, but when combined with its size, it becomes striking. Together, these two characteristics alone would have guaranteed intense scientific interest. Yet the detail that truly transformed the tone of the conversation was the confirmation of its origin. The robotic Atlas telescope first detected the object as a bright point moving steadily across the starry background. Within less than 24 hours, astronomers around the world began calculating its trajectory. Observatories coordinated, data flowed across continents, and orbital models were refined with remarkable speed. The result was clear and unequivocal. This object does not belong to the solar system. Its path is hyperbolic, meaning it is not gravitationally bound to the Sun. It is not a long-period comet, returning after thousands of years. It is not a distant asteroid, nudged inward by planetary interactions. Its orbit tells a far more dramatic story. It came from outside our stellar neighborhood, from another star system, and after a brief visit, it will continue its journey into the depths of interstellar space. Up to this point, everything remains firmly within solid observational science. But then came the element that ignited the controversy: the route it follows as it crosses our planetary system. 3I Atlas follows an unusual path, passing relatively close to several planets: Mars, Earth, Venus, and then Jupiter. The probability of an interstellar object crossing the solar system along such an aligned trajectory has been estimated at less than 0.045%. In simple terms, in 99.99995% of cases, an interstellar visitor would pass through the system without coming close to any planet. But this one appears to have chosen a route that maximizes planetary encounters. This is where the narrative stops being purely astronomical and enters the territory of more daring hypotheses. Astrophysicist Avi Loeb of Harvard became the most prominent voice, suggesting that we might not be dealing with a purely natural object. According to him, the trajectory appears too precise to be entirely random. Instead of a casual orbit, it resembles something closer to a flight plan. The idea is controversial, widely criticized, and far from representing scientific consensus. But it raises a powerful question. What if it is not just a rock? This is not the first time science has found itself in this kind of debate. In 2017, the world encountered Oumuamua, the first interstellar object ever detected. It crossed the solar system quickly and left three major mysteries: unexplained acceleration, unusual shape, and the absence of a visible cometary tail. Some scientists even suggested it could be a technological probe. Most of the scientific community, however, favored natural explanations: dust-poor comets, exotic ice, or invisible hydrogen outgassing. Even so, the mystery was never completely closed. Now comes 3I Atlas, larger, more massive, and equally intriguing. At this moment, it is crossing Mars's orbit and continuing its approach. In October, it will pass relatively close to the red planet. In December, it will make its closest approach to Earth at about 67 million miles. Distant in human terms, but practically next door on a cosmic scale. Then it will continue toward Venus and later past Jupiter before leaving the solar system once again. This sequence of planetary encounters lies at the center of the controversy. Loeb suggests that if it were a probe, this route would allow the study of multiple planets in a single pass. A kind of interstellar reconnaissance mission. It is a speculative hypothesis, but one that draws attention because of its internal logic. There is also a curious detail. The object will pass much closer to Mars than to Earth. One intriguing hypothesis proposes that its closest approach to Earth will occur on the opposite side of the Sun. It will be illuminated by sunlight, ideal for telescope observations, yet invisible to us because the Sun will be in the way. Coincidence? Chance? Or simply orbital geometry? The speculation goes even further when considering the possibility of gravitational assists. Our own probes have used these maneuvers for decades to gain or lose speed. An object passing near multiple planets could, theoretically, use these interactions to slow down and remain in the solar system longer. But here comes the essential counterpoint. The vast majority of scientists do not agree with this interpretation. Recent observations show a diffuse glow around the object, a cometary coma typical of ice-rich comets. As it approaches the Sun, this glow should grow. This points to a much simpler explanation. It is a massive interstellar comet. And when we talk about size, it is not as exceptional as it may seem. Comet Hale-Bopp had a nucleus about 46 miles wide. Bernardinelli-Bernstein reaches an astonishing 85 miles. In this context, 3I Atlas is large, but not extraordinary. The most accepted explanation is straightforward. A comet ejected from another star system, something that must happen billions of times across the galaxy. Even so, the story does not end here. Its trajectory suggests it entered the Oort cloud around 8,000 years ago, a period that coincides with the emergence of the first human civilizations. It is merely a temporal coincidence, with no scientific evidence of a connection, but it inevitably fuels the imagination. This type of conversation often leads to the concept of the dark forest, inspired by the Fermi paradox. Where is everybody? The idea suggests that advanced civilizations might avoid revealing their presence out of fear of cosmic predators. It is a philosophical hypothesis, not a scientific one, but it shows how astronomical discoveries can touch deep questions. Even if 3I Atlas is just a comet, it is incredibly valuable. Interstellar visitors are extremely rare. The first was Oumuamua, the second, 2I Borisov. Now we have the third. Each of them is a time capsule from another star system. They carry information about planetary formation, interstellar chemistry, and the evolution of solar systems. They are, quite literally, free samples of the universe. That is why the scientific community wants to observe it as much as possible while it remains visible. The case of Oumuamua showed how much we can lose when we are not prepared. Today, there is even a proposed mission called Project Lyra, designed to intercept future interstellar visitors. Perhaps the true legacy of 3I Atlas will be to accelerate these plans, because there will be others. The galaxy is full of them. In the end, the story of 3I Atlas reveals something fascinating about science. It advances through questions as much as through answers. Some hypotheses will be discarded, others will be refined. Often, the truth turns out to be simpler and still more incredible than we imagined. Perhaps it is just a rare comet. Perhaps it is simply a cosmic messenger with no intention at all. Or perhaps it represents the beginning of a new era in astronomy, the era in which interstellar visitors will stop being rarities and become targets of space missions. Whatever the final answer may be, one thing is certain. We are living in the moment when humanity begins to observe objects from other stars in real time. And that, by itself, is already extraordinary. If you enjoy this type of content and want to follow the next chapters of this cosmic story, don't forget to like the video, subscribe to the channel, and leave in the comments what you think 3I Atlas really is. A simple comet, or something we still don't know how to explain.